we all kind of take the HDMI cable for granted. You know, you plug it in, you get a picture, and that's it. But copper, the actual wire, has a hard limit. You try to run a high-def signal past, what, 50 feet?
And you hit what's called the digital cliff. It's not a graceful fade. The picture just dies.
It's just gone. And that is the exact problem we're looking at today. We're going to be digging into the NTI ST-FOHD-SC50 HDMI extender.
Exactly. This is the professional solution.
And just to be clear, this is not some booster you'd find at a big box store. This is a total shift in how the signal is even sent. Our mission here is to see how the pros get around the physics of copper by just switching to light.
Right. And this is a serious piece of kit. It lists for about $1,170. It's designed to take that HDMI signal and put it over a single-strand Multimode SC fiber optic cable.
That single strand part is what gets me. I mean, an HDMI cable has 19 separate pins, 19 wires all doing their own thing.
Yeah.
Putting all of that synchronized data onto one tiny strand of glass? That sounds like a serious engineering challenge.
Oh, it is. But the payoff is just massive. The biggest win, really, is immunity.
Immunity to what?
To noise. Think about an industrial setting, like a factory floor, or even a hospital near an MRI machine.
Okay.
All that equipment puts out a ton of electromagnetic interference, EMI. And a long copper cable acts like a giant antenna, just sucking it all up.
And that would just corrupt the video signal completely.
Totally. But fiber is just glass. It's non-conductive. You could literally wrap this cable around a high-voltage line, and the signal wouldn't even flicker.
Wow.
And because you're not fighting electrical resistance, the distance just explodes. You go from that 50-foot maximum to 980 feet.
980 feet. That's almost 300 meters.
300 meters.
That's nearly 3 football fields. So, okay, but when you push a signal that far, you have to expect some kind of compression, right? Some latency. How does the video fidelity actually hold up?
It's surprisingly solid. It handles uncompressed 1080p at 60 frames per second and computer resolutions up to 1920 by 1200 with no problem.
I did notice one little catch in the specifications, though, when it comes to 4K. It says it supports it, but only at 30 hertz.
Yeah, and that's a really important distinction. For a gamer, 30 hertz is a non-starter. It's just going to look choppy.
Right.
But for the real audience here, we're talking digital signs in an airport. Medical imaging displays 30 hertz is perfectly fine. Static images look great. And it keeps the whole audio package, too. Dolby True HD, DTS HD Master, full HDCP compliance.
Okay, so let's talk about the actual hardware. For something that costs over $1,000, it's tiny. These are basically just dongles.
Small form factor, yeah. They plug right into the HDMI ports. The really clever part is the transmitter, the side that plugs into your computer. It actually draws power from the HDMI port itself.
Ah, so no ugly power adapter on the source side. That would really clean up and install in, say, a server rack.
It does. Now, the receiver at the other end by the screen, that does need its own AC adapter. But, I mean, you're plugging in a monitor anyway, so there's always power right there.
And that design, having the dongle separate from the cable, that must be huge for installers. You can't really pull a big, clunky HDMI head through a wall conduit.
Can't, but you can easily pull this thin little fiber strand through and then just click the extenders on at each end after the fact.
Which is why this is TAA compliant, I'm guessing. It's built for those kinds of permanent government-level installations.
Exactly. TAA compliance means it's approved for federal contracts. So you're looking at situation rooms, secure facilities, places where the infrastructure has to be perfect and tamper-proof.
So it's basically the bridge. It connects the consumer interface that's on every device HDMI with that industrial-grade fiber infrastructure.
It perfectly solves the two big problems, distance and interference.
It does make you wonder about where all this is headed. I mean, with 8K, with virtual reality, we're pushing so much data that even short copper cables are starting to strain.
We're definitely approaching a wall. It makes you think we'll reach a point where fiber isn't just for the 300-meter run across a factory. It might just become the standard for the 3-foot cable running from your game console to your TV.
Simply because copper can't keep up anymore. A future made of glass. Thanks for listening to this deep dive.